All right, Dave. Well, welcome back to our offsite location for the Wood Tech Series.
Thanks, Jim.
Hey, one more time, you're going to be tackling something that I'm vaguely familiar with, so I'm really excited. You're going to go over routers today.
Okay.
So I thought we got a few tools on the table. Maybe you could kind of run us through. I'm assuming there's differences in each. So why don't we start there?
All right. Well, what we've got here are the three basic type of router. And, you know, when you think about it, a router is kind of like a drill motor without a handle, okay? Oh. It's just a motor. You affix a bit onto it, and we'll talk about how that's done. But it's spinning much faster. Your drill motor may be spinning at maybe 2100 for the maximum RPM. These are more like 27,000 RPM. So They're going really fast.
Wow.
When these bits are hitting the wood, and it doesn't have to be wood, it could be solid surface material, it could be many, many different kinds of material. They leave a very polished surface. You know, when you cut with a router, it's kind of like a lathe. A lathe produces a finished product. You may sand it a little bit, but it's a finished product. And routers are incredibly versatile. Interesting thing, a little background, this tool came about in, it was 1919, and a pattern maker, and pattern maker is sort of the highest level of cabinet maker, making these very, very machine to perfection kind of molds, and these molds would then be cast. So we had to make everything to a military spec. And the problem was, in the Industrial Revolution, we had big spindle shapers. And they looked like tables with a spindle coming up. They were, loose knives were affixed to them, and you could make moldings and do all sorts of things. But it's hard to bring something that's really big onto a table. Yeah. And it was equally hard when you have something with a lot of curves or different odd shapes. So what he did was he stayed up one night, and he took a set of barber's clippers and literally took the motor off, took the worm gear, ground the gear into a 3/16 round over, and he did what it was estimated 7 men would take with a molding plane and spoke shaves. He did it in 2 hours. So after that, he realized there was a lot of utility, and he started this tool, the R.L. Carter Company. And after 100,000 routers were made in 1929, Stanley bought it and came up with the Wonder Tool. Now, these things are used everywhere, and one of the upper level uses now, or one of the most common, is in a CNC machine, a computer numerically controlled machine. So that's where we actually do the design in CAD, we transfer it to tool code, and then you tell the path you want the router to take. And this is the way most of our parts are being made these days. And it's basically just a very simple router head.
Okay.
Okay, so the three that we have here are going from, you know, baby bear, mama bear, papa bear. Basically, they're small to big, but they're with a lot of differences. This one is considered a laminate trimmer or a trim router, and it's used for smaller diameter bits. All right, as we start to climb up, we'll start to use bigger bits, and there's different ways that these are held. Almost all the time, when you have a router, the base, the motor is going straight down, and the base holds it at 90 degrees. And this is what's considered a fixed base router. This being a very common one here. And you can raise and lower the router and then fix the base wherever you're going to go.
Okay, and you're raising it, lowering it for the
depth of the cut.
Okay.
And some of the cuts, depending on the profile of the bit, are going to give you a deeper cut. It'll give a different look completely. Okay. So fixed base. And then we have what we call a plunge base, Jim. So this one basically goes down. We have a turret right here, and I can go down at different heights. So if you can imagine, I'll just put a straight bit here. It's a very cool tool because you can do inlay work and all kinds of work. I'm just going to quickly put this in because I'd like to show you what this machine does. It's completely different. It's a plunge base versus a fixed base. But what happens is, because you can set the depth, I can go down to 0 and I can lock that base in place. And that is 0, so it's right at the top of whatever material you're trying to work with. Okay? And if I wanted to, say, inset this into a piece of material, I would just pull up this little pin here, and I would put that in right there. Now when I plunge down exactly that depth.
Do you use something like, sometimes you go to somebody's home where they've taken a lot of time to do a really nice hardwood floor that's got inlays? Is that the type of thing?
And that would be the thing that you would use, yeah.
Okay.
You know, hardwood flooring, there are people that do nothing but what we call marquetry, if you will. But basically, it's beautiful patterns and or literally a picture. And they do it in different woods. And I've seen it done on some homes where they've actually had a compass rose all inset.
Wow.
And this is exactly the tool that they would use.
I'm assuming you're not, if I'm somebody's beautiful floor, I'm not freehanding that. I'm setting up some guides or patterns around me that I'm running it against.
Exactly. You're setting up a pattern.
Okay.
Yep.
Okay.
And then, of course, you'd be inlaying whatever kinds of wood you want.
Very cool.
It is very cool. And then, of course, you just plunge up and down. Okay. There are so many uses for these things. You think of joinery, doing a dovetail joint or a rabbet joint, easy with these tools. Okay. You think of the CNC work for copying, duplicating, and then edge forming. Edge forming is what most carpenters would use it for. Maybe they're trying to put a radius on something and they want different size radii.
Okay.
They can select what they want.
Maybe just for our audience and me too, could you just talk quickly about a dovetail versus a rabbet joint? Just I don't know
Absolutely.
if you have to show it or if you can just explain it.
Maybe I can do it in air. So basically, a rabbet is just an L-shaped cut on edge or end of a board. Okay, and a lot of times that will actually kind of self-index, and we can use that to make a joint, a rabbet joint.
Like jam stock.
Yeah, exactly. That's exactly it. Yep. And on a dovetail, it's an interlocking joint. So when you cut with that bit, it's kind of a V shape.
Okay.
And when you cut pins on one side and a dovetail on the other. And when they intersect, they actually lock together.
Okay.
That's considered very high quality for something like a drawer or whatever.
Gotcha. Are there limitations to that one? Are there things that I might want or need to do that I can't do with a plunge, or does that thing do it all? Plus,
it kind of does it all, but it is, you can see it's a pretty top-heavy piece of machinery.
Yeah.
We like to keep something a little bit, closer to the ground. All of these, you can see here for this trimmer, and this is a cordless trimmer, which I'm astounded that I'm so happy with, but it is a top-heavy piece of machinery. And one of the first projects that our students do is actually a laminate cube, if you will. It's 6-sided. And they'll notice that if they tilt that, they will actually burn into the plastic laminate. So you have to hold it down and push forward. Now, it's nice when you've got both hands on it and you can really keep it down. As you said, with patterns and everything, there is no end to what you can do. Let's say for one of your pieces here, you wanted to make a bowed front on a cabinet or countertop or something like that. In order to get that perfect radius, what you would simply do is you'd lay out what the distance was on a piece of plywood. You would put a nail or a screw in one end. You would fix the router and its base onto the other end. And when you turned, it acts as a trammel and you get perfect circles.
wow.
Or in this case, part of a circle.
Okay. Going back, graduate from wood tech, carpentry, I'm going to buy a router. Do I go this route as a starting point, or do you need a couple to get going? Or?
This is a real interesting point. We like Porter Cable because basically anything that survives in core for a year, you'll be passing down to your great-great-grandkids, okay? So we like it because it's been pretty rugged. But the other thing is, if you have this one motor head, you could put it into a variety of bases. So I have one here that is a D handle, which we like a lot. It's the same head.
Okay.
That same head can also fit into your plunge router.
Oh, wow.
So this is a normal kit, which is a fixed base and a plunge base in a kit. And it's worth every penny because it allows you to do many different things.
Right.
This, if you're using a router a lot, this is heaven, because instead of a toggle switch, you actually have a spring-loaded trigger.
Nice.
Yeah.
Nice. Limitations for this one? Can you get in the weeds with that?
Thank God. Okay, thank God there are limitations. And I'll show you what the big limitations are. The big limitations are the size of the collet. Now, this is different than a drill motor. You think about a drill motor, you have usually a 3-jawed Jacobs style chuck. And those 3 jaws are biting down onto a cylinder. It's not going to work for something turning 27,000 RPM. So in this, you have sort of a tapered cone. You stick the cylinder into this tapered cone, and you've got a nut that will drive that cone down and hold the entire bit. So, if you will, it's kind of like holding it like this all around. And it's just a better way to put these in. But again, at that kind of speed, you need a better way to hold it.
Okay.
And these are called collets. Now, the collets come in 1/2 inch and 1/4. That's standard. So when you buy a router, you will get 2 collets. Fortunately, when you buy a trim router, you only get 1. Okay. And that's a 1/4 inch collet. So this is an interesting thing. On these 2 bits, and I know we're going to be covering bits later, you'll notice one is a 1/4 inch shank and one is a 1/2 inch shank. They can be identically the same bit, but if you have it with a 1/2 inch shank, there's a little less vibration. It's a smoother operation. It is a little bit more money, but oftentimes if I've got an 1/8 inch round over bit, which is what we call a bullnose bit, on that 1/8 inch, if I have it in a 1/2 inch shank, it's going to be a smoother cut. But this will not fit in the trim router. I say thank God, because people will try to stuff very large bits into tiny tools and they will get themselves in trouble.
Gotcha.
These can handle some pretty good sized bits.
Yeah. Speaking of bits, I know in our earlier conversation you were talking about a proper way to install them and maybe more so a proper way to take them out.
The big thing is you don't want to lose the skin off your knuckles.
Yeah.
So here's an easy way to do it that I like. On all the fixed spacers, this one's more difficult to do, so you just literally have to lay it down to the side. Okay? So what I will do is I'll put the collet in, the appropriate collet. In this case, it's a 1/2 inch bit.
Okay.
I'll drive the bit home, and this is what everyone doesn't realize. If you put that bit all the way in and bottom it out, then when you start tightening, it actually forces it out. So with this bit, it's all the way in and out 1/8 of an inch. Always, on all routers.
Meaning you're pulling it back out.
You're pulling it back out 1/8 of an inch.
Okay.
And then you tighten it by hand. Okay.
Now, is that just with a 1/2 inch bit or with any bit?
With any, I could do it with a 1/4 inch collet or anything. And in that tool too, for a trimmer, it's always all the way in and out 1/8 of an inch.
Okay.
Otherwise, you bottomed it out, and as you tighten, you're actually driving the bit actually out of the tool.
Okay.
And then they wonder what happens when it falls out.
Okay.
So for this, I can then come, and I like just laying the router on its side. And so I'm going to be tightening this in, and it is righty-tighty on this one.
Okay.
And I'll simply lower it down and then push open-handed. And if you'll notice, I'm not putting my fingers between. This open-handedness means you're good to go. And then once you got her snug, you put your base back on. This is kind of a spinny base. It gets deeper and deeper depending on where you are that way.
Okay.
And then lock it in place.
Okay.
And then taking it out is the same. And the reason I'm going to go taking it out here is to show you what happens. Sometimes when you go to take out a router bit that's been worked on hard, okay, it doesn't want to come out.
It doesn't want to come out.
It doesn't want to come out. It's in there pretty hard. And it could have been that you over-tightened it a little bit. So the easy way to do this is just tap on the nut. Don't tap on the bit. You'll shatter the car pipe.
Okay.
Just tap on the nut, and then this will come out much easier.
Gotcha.
Okay? So taking a bit, or putting a bit in, taking it out, that I think is a real basic that people should know.
Okay. Fabulous. One of the big things I wanted to pick up specifically in the router segment was safety.
Well, we've all seen different horror stories, and a lot of times it has to do with the bit in the tool. So let me just show you this one, Jim. So I'm going to turn this on. 1, 2, 3, 4, and that's fast.
It's
a lot of times it'll be up to 10 seconds before that stops. And you know that builders are very patient people, right?
Oh, yes.
Yeah, okay. So we're diving in to move something, or I've got this on, I turn it off and I move.
Yeah.
And that's when things happen.
Sure.
So one of the things is letting the darn thing stop.
Okay.
Okay. The second has to do with the tooling itself. And I've got another router here. This is a more modern router. One of the things that can be added, it can be aftermarketed, is this. It's speed. This has a little bit to do with safety. You'll see in a minute. What I can do, I can have it fast. where I can slow it down depending on the material I'm cutting.
Okay.
If I'm finding that it's wood and I'm burning, I might be able to slow that down. Or maybe I'm not cutting wood, I'm cutting some other material.
Okay.
So it's nice to have the speed change.
Okay.
But what's really magical about this is this. It has an intelligent switch, but most of these just have a rocker switch. So what happens is it gets nicked, it gets done. A lot of times in the shop, someone will put it away, they'll grab something the wrong way.
It's on position.
Yeah, and what you see is that torque coming in. It's very reminiscent of a skill saw. If you have a worm drive saw, there's a phenomenal amount of torque.
Yeah.
Now, if you have a sidewinder or a direct drive saw, when you turn that on, if this were to actually happen, wouldn't be a problem. So one of the new safety features, so the torque is not instantly transmitted to you, is this. Now I've got this machine on. It's called soft start.
Oh yeah.
And you'll notice that it didn't do what this one did to immediately go on. And this is a fairly small router. When you get to one of the big Speedmatic routers and it's 2.5 horsepower and you watch that torque just go instantly, it's the one thing I have to train a lot for. You think of a miter saw, that's a trigger that's actually a spring-loaded trigger. You think of a skill saw, same thing, spring-loaded. But these are not. They're usually some kind of toggle or rocker switch. And again, just as I say with saws and everything, same thing with router bits. You don't want to start this tool with the router bit against the wood. Okay. You want to be a little bit off and then come in.
Excellent. Can you talk about just some basic uses? You obviously laminate trimmer and things like that, but in inlay, is there some other things that
I do a lot of pattern work when I'm on site. So a classic would be something like a door. I would have a pattern for a latch that I'm putting in, or a deadbolt. Okay, real common for carpenters. And I usually do that with a trim router. I have small patterns made up. Think about letting in a hinge. Okay, you're going to put in a new door and you've got to let in a hinge. You got to make the gain for the hinge.
Gotcha.
So you would put that in. Edge forming, of course, of all kinds, roundovers being the most common, but you could have some decorative edge that you were putting on.
Okay.
And then if you needed to hog out a lot of material, maybe a straight bit. And we'll get more into that with bits, but you can have stop collars and all sorts of things. There was one I was going to show you that I used to do a lot of cabinet work where I had a pull. So it was a drawer behind a door. So you'd open the door and you'd pull the cabinet. I don't know how many drawers that thing has made, but that pattern has been used and used and used. It's at least 35 years old. So patterns like that make you a lot of money. And as a remodeler, that's what you want.
That is so awesome. Well, I really appreciate you doing this series. Looking forward to the next one.
Okay, thanks, Jim.